Okay, here we are with a question about parallel conducting plates. We're going to be looking at the acceleration between those two plates. We're being asked to calculate a few things, the electric field and the change in kinetic energy. As ever, hit pause, try the question, and when you're ready to see an explanation, press play. Okay, so we're going to have a look here, look at our values. We know that our conducting plates are separated by 50 centimeters. We know the potential of one plate is 200 and the other is 450. This is not a conventional way of presenting potential differences. However, I hope that you're able to get it once we see this explanation. So we're going to start off by calculating the electric field strength. We are assuming here that the electric field strength is constant. We're assuming that 50 centimeters is a relatively small number, okay, and therefore we have a uniform field, and we can use this equation, E equal to V over D. Now, the big question here is, what is V? V here is the potential difference, not the potential. So if we have a 200 and a 500, then we are going to be thinking here about the difference between these guys. 450 take away 200, which is going to give you 250 divided by 0.5. Noticing here I've changed my distance into meters, and that gives me a magnitude of 500. So we're going to get rid of C and D. And the question here is, are we gaining or losing kinetic energy? And I quite like this one. Notice here we have a proton, and it's traveling from a positive plate to an even more positive plate. Now, remember, positive things repel each other, okay? And so therefore, we're going to have our proton slowing down. In other words, it's going to work against the field, which is why the change in kinetic energy is going to be negative. Put simply, it's going to be slowed down by the more positive plate that it's traveling towards, and therefore, as it slows down, speed goes down. That means kinetic energy also decreases, meaning the change in kinetic energy is negative.